Hey, Teacher Sam.
What's up, Ivan?
I was having a really hard time understanding graphs. I was wondering if you could help explain them to me.
Yeah, of course. So there are a couple main things that we want to go over.
Okay.
To start off, just understanding the graph. So this is the main graph we're going to be looking at through most of today's video.
Okay.
It has two axes. That's the sort of center pieces that go right and vertically. That's what you reference everything against.
Okay.
There's the x-axis, which is horizontal, which means it goes side to side. It starts at 0 and increases as you move to the right.
Okay.
Then there's the y-axis, the vertical axis, which starts at 0 here and then increases as you go up.
Alrighty.
And then this 0 point, which both x and y, their values both 0, that's called the origin.
Okay. So just to make sure I got it right, horizontal means side to side,
Yep.
vertical means up and down,
Yep.
and the origin is 0, 0? It's
Exactly.
the center part?
Yep.
Okay, great. Sweet.
So, and when we're looking at this picture, it's just going to be there in the bottom left all the time.
Okay.
So moving on to plotting some points. We've got this same axis picture, and we're going to look at x equals 2, y equals 3 first. So the way we want to do that, x equals 2, we draw a line up from x equals 2. Along that line, x equals 2 no matter where you are along that line.
Okay.
And then for y equals 3 no matter where you are on that horizontal line. And so the intersection is where x equals 2 and y equals 3. Now, if we look at another example, x equals 4, y equals 1, start at 4 for x, draw that line, draw across from y equals 1, and that intersection is x equals 4, y equals 1. So why don't you try graphing 0, x equals 0, y equals 5.
Right. So I have a question.
Yeah.
If x equals 0, am I supposed to draw the dotted line on the 0 line?
So that's a good question. If it's on the axis, you don't have to, because you know it's going to fall along that line. So
Okay.
you only have to look at the number that's not 0 and mark it there.
So then, since y equals 5, I can just go 5 on the y-axis
Yep,
and circle it?
just like that.
Wow, sweet.
So next up, for everyone watching at home, just pause the video here and go through and look at these pairs. So the pairs here, this means x equals 2, y equals 3, x equals 5, y equals 1, and so forth. Go ahead and graph those. Just grab a sheet of paper, draw out an axis, and pause the video, and then in a second, we'll go over what it should look like. All right, so going through this quickly, x equals 2, y equals 3, that first point is there. X equals 5, y equals 1, that second point is going to be right there. X equals 1, y equals 2, it's going to be there. X equals 0, y equals 2 is going to be there. And x equals 4, y equals 5 is going to be up here. So check that with what you did when you paused the video and see if you got them right. Now, moving on to the next part, ordered pairs. So ordered pairs is just a different notation, which is just a different way of writing things. So everything we've looked at so far is, x equals 1, y equals 3. And even when we used this notation over here, I told you that means x equals 2, y equals 3. But there is an easier and shorter way of writing that, which is where you put the x value first and the y value second and put a comma in between them. So x equals 4, y equals 5, you write as 4, 5. And that's called an ordered pair, and you're going to be seeing that just about everywhere you go. So do you want to try the next two?
Yeah, okay. So I think it'll be like that?
Close.
Oh.
So you have the right two numbers, and you've
Okay.
got the parentheses and the comma, but you actually want to do the x value first. So instead of that, you want it to be the 7, this value first, and then the 2.
Okay, okay.
So do you want to try the next one?
Yeah, okay. So you said the x values first.
Yes.
So then it would be 2, comma, y value is second, 3.
Exactly.
Okay.
Nice. Now, if you've got more axes, which as you get older, you'll start to see, z-axis, which will usually be the third, and you might even be dealing with more after that. The additional numbers just go to the end. So 2, 3, 6 means the first two are the same, x equals 2, y equals 3, but then the third axis, the value is 6.
Okay.
So same thing as before. At home, pause the video, draw out an axis, and this time you're finding these 3 ordered pairs on that sheet that you have. So 2, 1 is going to be right here. 3, 5 is up here. And then 7, 2 is way out over here. Now, moving on to the quadrants and negative numbers. So far, we have only been looking at quadrant 1. If you just isolate this, that looks exactly like what we've been talking about, where all the numbers are positive. But this same concept applies the exact same way with negative numbers. So we call these the 4 quadrants. Quadrant 1 is what we've been talking about, where both x and y are bigger than 0. Then as you move counterclockwise, quadrant 2 is next. X is less than 0 because it's to the left of that center spot. Y is greater than 0 because it's above that center spot, or to the left and above the origin. Now quadrant 3, both are negative because it's below the origin and it's to the left of the origin. So you see that here, both less than 0. Lastly, quadrant 4, x is greater than 0 because it's to the right of the origin, and y is less than 0 because it's below the origin. Now, we'll go through graphing these points. I'll do the first 1 or 2, and then you'll take over after that.
Okay.
So 4, negative 3, same thing. We draw the line at x equals 4. Let's draw a better line than that. And then for y equals negative 3, instead of going 3 up above, we're going 3 down below. And so we're drawing the line there. And that intersection is 4, negative 3. Now what quadrant do you think that's in?
I think that would be in quadrant 1, 2, 3. I think it's 4.
4,
Okay.
right. Because the x value is greater than 0,
Okay.
and the y value is less than 0.
Yeah. Okay.
So then 0, 0, well, that's just the origin. That's right there. What quadrant do you think that one's in?
Would that be in quadrant 0?
Well, there isn't really a quadrant 0. It's sort of a trick question. You can say that's in all of the quadrants. You can say it's in none of them. It's not really defined what quadrant that's in, but there's just the 4 quadrants.
Okay.
So now do you want to try those remaining 2?
Yeah. So, you said we have to start with negative 1. We have to draw a line. And then we go 1. The intersection is right there. Oh, right there.
Yep, just like that.
Okay.
Now try that last one.
Negative 3 is here. Draw a line. Negative 2 is down here. And where they intersect, it's right there.
Nice. And so what quadrants are those 2 points in? First off, negative 1, 1. What quadrant is that point in?
That one is going to be in 2.
Nice. So you can both look that
Yes.
x is negative and y is positive, or you can just reference this and say, well, 2 is the second one counterclockwise starting from the top right. How about this point down here, negative 3, negative 2?
Down leaves us with quadrant 3.
Yep. And you can look at that here,
All right.
or you can look at the fact that they're both less than 0. Now, moving on to addition and subtraction. This concept, it might seem difficult at first, but it's really just as easy as adding the 2 x and y values. So remember, 2, 4 means x equals 2, y equals 4. 1, 3 means x equals 1, y equals 3. And so when you're subtracting these two, it just means you're saying x equals 2 minus 1, y equals 4 minus 3. And so this, you just subtract the first elements, 2 minus 1, and the second elements, 4 minus 3, and then you plot 1, 1. For this second example, it's addition, but the same thing. You add up the first 2 numbers, or the first number of each ordered pair. 3 and negative 1 makes 2. Then the second, negative 1 and 4 makes 3. And then you plot it right there. Now why don't you give the third one a try?
Okay. If we're subtracting 5 and 3, that should give us 2. That one should give us negative 3.
Close. So if this is negative 1 and you're subtracting that, you're subtracting negative 2. So you're going to want to add that to essentially because you're subtracting a negative, leaving you with 1. So it's going to be 2, 1 right here. Now, the last two things we're going to look at are getting a little bit advanced, but they're really important as you move further on. So first off, some basic functions. So a function is just you have something that goes in and something else comes out. And the way that you'll see this drawn is usually a box with a question mark. And so you have some value on the input. In this case, it's x. It goes through that function, and now it's the output. So in the case of y equals x, that function is just, you have the same number. 3 goes into the box. The function is y equals x. And, because x equals 3, the output is y equals 3. So now moving on to how we graph that, you're going to want to fill out a table like the one we saw up above, and then fill out a couple of values. All of these 3 equations that I've put up here are lines. So you're going to want to fill out the values, -4, -2, because remember, x is just the same as y. And then you're going to plot all of these. So that's -4, -4, which is down below here, -2, -2, 0, 0, 2, 2, and then 4, 4. And then what you can do is just draw that line right between them. Now, as you get to more complicated functions, which we're not going to talk about today, you can't just draw a line, as simple as that. But for now, it doesn't even matter how many points you put. If you draw a straight line through them, it'll be correct. So, y equals -2x, a little more complicated, but it's the same concept. It's a function. Say you put in x equals 3 into this function. Function is y equals -2x. The output that you get is y equals -2 times x is 3 is the input. -2 times 3 is -6. Y equals -6. So now we're going to, again, plot that using the same technique. So y equals -2x. For 4, that's going to be 8. For -4, that's going to be 8. -2, that's going to be 4. 0, -4, -8. You just apply that function to each one, and then you plot it. Well, -4, 8 is outside of what I drew on the graph. So let's just plot -2, 4 first, then 0, 0, and then 2, -4. Again, we can't reach 4, 8, -4, 8, or 4, -8, but we already have enough. Because we know that it's a line, we can just draw that point through, and we actually know that that line will go through -4, 8 and 4, -8. Now, do you want to try this last one, y equals x plus 1? Start by filling in the table and then graph it.
So then, -3, -1, 1, 3, 4.
Close. You want to make sure you're adding 1 to every single element. So for 4, you want to add 1 and you get 5. And so you just go through, you apply that function, which means you just, in this case, add 1. You have your new set of x and y.
So start there, and then I start -2, -1 is there.
Yep.
I do 2, 3, which is 1, 2, 3. I go -4, 1, 2, 3, 4. Then I go down 3, 1, 2, 3. And then I go 4, 1, 2, 3, 4, up to 5. 2, 3, 4, and 5.
Nice. And then you can connect them by drawing the line. And again, this earlier line that just got cut off is right there. And now you know that any point on that not so great drawn line on my part is going to fit this y equals x plus 1, which means you can take any value. Let's say that this right here is going to be 3, 4. Plug in 3 for x and 4 for y, and the equation checks out. 4 is equal to 3 plus 1. Now, the very last thing that we're going to go over today is linear functions. And so it sounds complicated. It's exactly what we just did. Linear is just a line. And so, all of these, I said, they're just lines. And then functions is what we're, again, just doing. So the way that you write linear functions typically, and you'll learn different ways of writing this, is y equals mx plus b. So y and x are the same as they were before. M and b are two new variables we're introducing. So m is called the slope, and it's rise over run. And so in this case, let's go to this one. Rise is the change in the vertical component. So from this point to this point, you go 1, 2, 3, 4. You go down 4, and then horizontally you go over 2. So the vertical change is -4. The horizontal change is 2. So the slope, which we're calling m, is -4 over 2, which equals -2. Now, that just determines, if the line looks like this or this. It doesn't change the actual position of it. It just shows the angle of the line. So that's just going to be m. And so you can quickly see with y equals x plus 1, m, which is there, is 1, because that's the same as saying y equals 1 times x plus 1. And so for each of these points, the rise, here 2, is the same as the run, also 2. It changes in x and y the same amount. So that's our slope. These are examples. Slope equals 2. You see that it goes up 2 and over 1. Slope is 0, means it doesn't change vertically, it just changes horizontally. Slope is -3, it goes down 3 over 1. And then slope equals 1/2, which, if it's a fraction, you can just flip it. That means that it goes over 2, which is on the bottom of the fraction, and up 1, which is on the top of the fraction. Now, the last step before we can put this into practice is the intercept. So the intercept is b. So these two, what do these two graphs have in common?
What do they have in common? They both have slopes.
That's true. They do both have slopes. What else? Is there a point that they both pass through?
The origin.
Yes, they both go through the origin. And so the way we can think about that is y equals mx plus b. So y equals 1 times x. There's no b term, so it's just plus 0. That means that it intersects with the y-axis at 0. Here, again, b is equal to, is equal to -2, and b equals 0. It's y equals m, -2, times x plus 0. The y-intercept is 0. Y-axis, you find 0. It goes through that point. Now for here, y equals 1x plus 1. The b term is 1, which means you find, and I'll switch over to green here, where the y-axis, where y equals 1, that point, which the line is supposed to go through, and you know that it goes through there. So anytime you're graphing a linear function, you can go start at the intercept and work from there. So let's work on graphing these 3 lines, or these 4 lines, and then that'll be it for today. So start off with y equals 1/2 x plus 2. What's the first thing that we do?
I believe we plot it was the y-intercept.
Nice. And so this is the slope, this is the y-intercept. We say y equals 2 is right here. And in general, remember to label your axes, which just means putting x at the end of the x-axis and y at the end of the y-axis. So we have our y-intercept of 2, and we have the slope is 1/2. Now, what does the slope mean?
Slope, you said, mean rise over run.
Right. So this means that 1 over 2, what do we do with the fraction?
We flip it.
We flip it. So that means it goes to the right 2 and up 1. We don't have to plot any values. We just say, okay, to the right 2, up 1, there. We can do the same thing. To the right 2, up 1, there. We can also go backwards. To the left 2, down 1, there. And that's a nice and quick way of graphing that. And so instead of having to do the table, like we did up in these 3 cases, we just find the intercept, and then go from one point to the next, and then do the same thing in the other direction. So why don't you try, after I erase all of these, the next 3.
So we have to start with making sure our graph has labels.
Nice.
And we have to start with the y-intercept. Since there is none, it'll be at the origin.
Nice.
And question.
Yes.
So this one, the rise is 3, so I would just go up 3 and over 1?
Yes. So rise over run, 3 over 1 is 3.
Right.
And so it means for 3 you
okay.
go over 1.
So then I can do the same thing here. I can go up 3 over 1.
Yep.
I can go to the left 3, down 1.
Close. So even though you're going in the other direction, you still want to keep it where the vertical component is 3. So you go down 1, 2, 3, and over 1.
Okay.
Now do you want to go one more in the negative direction?
Right. You said go down, 1, 2, 3, down, over 1.
Yep. And so that line is going to look like that.
Okay.
Now, 2 more examples. And these are they each have different ways of being tricky. First one, y equals 4.
So since this also doesn't have a y-intercept, it'll start at 0?
Close. It does have a y-intercept, it just doesn't have a slope. Because since there's a constant term, which means a number without any variable tied to it, that is the y-intercept.
Since there's no slope, that means we can't draw the rise over run. Is this just a line?
Well, yeah, because there's no slope, that means the slope is 0. If there's
Okay.
no x, that's the same as saying 0 times x. So rise over run is 0. That means it goes up 0 no matter how far it extends horizontally. So yeah, this one is just going to be a horizontal line at y equals 4. Now how would you draw that on the graph?
Right. 1, 2, 3, 4. So the line will go right there.
Exactly. And so the rise over run is 0 because it just goes across no matter how, it stays at the same level no matter how far across you go, and the intercept is 4. Now, last example, x equals 6.
Let me think. I'm going to the right
Yes.
6 times.
Because it's positive.
Right. So I go 1, 2, 3, 4, 5, 6.
Yep.
And then I'll draw this line right there.
Nice.
Oh, I missed it by 1.
Well,
I think I...
no, you got it.
Okay, right,
That's 6.
right, okay.
All right, so those are all of the basic concepts for graphs. To review, we went over understanding the graph. The origin is that point in the center. The x-axis horizontal increases as you go to the right. Y-axis vertical increases as you go up. We talked about plotting points, how you just draw the 2 lines for the x value and the y value and find their intersection. Ordered pairs as just a way of doing that notation. Quadrants and negative numbers. The quadrants just being which values are positive and negative if it's to the left, above, below, or to the right of the origin. Addition and subtraction, just doing the first element of both of the ordered pairs and the second element of both of the ordered pairs. Basic functions, writing them out as tables. And then linear functions, where you use the slope-intercept formulation of it.
Well, thank you, Teacher Sam. I feel 100% more confident.
Well, thank you all for tuning in. Again, I'm Sam. This is Ivan. Like, subscribe, comment what else you want to see, and share with your friends.